I built this cool tool called SqueakPose Studio, and I'm going to do a quick walkthrough on how to download, install, and run the basic functions of the program. We're going to get started here. Go to the GitHub page. You can see everything that you need, and some sort of rough descriptions are listed. If we copy the clone URL and um, look in our documents folder, we can git clone this link. It will set us up with a new folder here. I would then implore you to open your IDE of choice. We're going to open up VS Code here, and we are going to open a folder. We're going to navigate to the clone package that we just pulled. And you can see all the files here, or all the files that you would see here. We're going to open a terminal. If you don't have UV installed, I would implore you to install it. If not, you can pip install period. It should pull the required dependencies for the package. We're shipping with a PyProject file here, which has all the dependencies and versions that they need to be. I'm on an M2 Mac Mini here. So using Apple Silicon, if you pull the Torch CPU bindings, you will get MPS acceleration. If you're on a Windows computer or a Linux build and have an NVIDIA GPU that has CUDA, it will automatically pull the CUDA 13 wheel files for building this program with GPU acceleration. What I'm going to do is just type UV sync in this folder, and what it will do is create a virtual environment for me and download all of these packages. UV is blazingly fast, which is why I suggest everyone to use it. And then if we type UV run main.py, you'll get hello from SqueakPose Studio, and you can see that we have a virtual environment here that is now activated. Just to make sure everything downloaded correctly, if we type UV run torch ultralytics checks.py, this is just a quick and dirty Python script to import torch, load the available versions. You see you have 2.9.1, MPS is available, so you have GPU acceleration on the back end. And then we're going to import Ultralytics and run the checks as well too, just to make sure that that package downloaded and is set up correctly and seeing your compute environment. To launch the GUI for the tool, what we are going to do is type run SqueakPose studio.py, and this will launch the GUI. What you see here is a blank GUI. There's no data loaded in here, but these are all the elements that you would see. We're shipping an example data set with this, so what I'm going to do is just cancel out. I'm going to go to the SqueakPose Studio folder. The first time that you run this with empty data, it will create the folders that you need and are necessary to train and manage your data sets. So this annotations, labels all, images all, and images to label folder. If I just go to the example data sets, you will see annotation, images all, images to label, and labels all. You copy and now paste these into this main folder, apply to all, and replace. You now have an example data set to explore and train the tool on. Again, we're just going to reopen the tool. And now you should see this example data set that's been loaded. I'm going to make this tool a little bit bigger. The tool will size to your images as you open them. On the top here, you have browse. You have the ability to search through your data set by labeled and unlabeled frames. You have a next and previous button. You can also use the left and the right arrow keys in the pan and zoom mode to go forward and backwards. Sorry, previous and next. So N and P keys to go forward and backwards. We have complete and move to the next labeled frame. If you click this on an already labeled frame, it will just resave the image. If you have no more images to label in your images all folder, It will give you this cute little pop-up that say that you've labeled everything. You can skip and go to the next unlabeled frame. Same thing. There's no save function there. And then we have a manual save. Um, this labeling mode, sort of GUI on the right-hand side, has the pan, zoom, bounding box, key point, and like model-assisted prediction modes here, all with hotkeys. So 1, 2, 3, and 4 on your keyboard. We're just going to go to 1 here. You can zoom with your scroll wheel or trackpad. Um, you can click and drag to pan around your image. And if you hop into the key point menu, you can see that we can toggle the labels with the L key. We can increase their sizes with the plus and minus keys on your keyboard. And with the bracket buttons, we can make the text bigger or smaller. We're going to go back into the pan zoom mode here. All of these are clickable and draggable. The box, the labels themselves. And if you click on a label or the bounding box and then click delete, you can unlabel or change any issues. We'll manually label here. If we click 2 to go into bounding box mode, you get some crosshairs. Um, we've been labeling just the body of the mouse. You want to draw a tight bounding box around the body and then go to 3. And you'll see in the bottom left side what key point you are placing next. This is just a left click on the body of the mouse, and then I'm just going to manually click save here, and you can see in the terminal window that we saved the image label and annotated image frame to these corresponding folders. What am I forgetting? We're pre-importing classes as mouse here. If you go into the Label Studio key points text file, you will see a list of key points. You can change these as you see fit. If you want to label more or less key points. And your classes.text is mouse, you can change this to rat, you can change this to human. This is just what's populating up here. This is sort of the initial hooks to build multi-animal support as well here too. The next thing that we can do is look at the video loader. So if we click video in the top right, you see that you get a video review panel. We can load a video. We haven't shipped any with the example datasets on GitHub because the files are too big. I can upload a small clip, but what I'm going to do is go to the example video dataset that we have and pick a video. This will load a video in. You can see that it will load the file, the resolution, and the FPS. We can start and stop. So if you want to just look at, the first 100 frames, we have stride, which I will explain here when we fire up a preloaded model. And confidence is to do predictions on these raw videos too. But before you do anything, if you're starting from scratch, you can just send a random number of frames to the labeler. I'm going to click 5 here. What it will do is automatically extract those frames, copy them to your images to label. And now if we go to unlabeled frames and zoom out, you now have 5 new frames to label in your data set. I sort of alluded to this, but we can click load model. We're shipping 2 pre-trained models for this example data set. So I go to my documents and go to SqueakPose Studio, go to runs. You will see a detect and a pose model. The detect models are bounding box only, so no key points, and the pose are models that have bounding box detections as well as key point placements. We go to weights, we load this .pt file. And now when we click 4 on the predict mode, it will run a single prediction on this frame. We can zoom in, drag back over to our mouse and see how well it's doing. These models are sort of lightly trained for demo purposes, but we can click in, move around. And then if we click save, we'll save those labels. We go back to this video loader, we're gonna load that same video again. And if we load this video, let's label the first 100, let's label all of them. Let's do 18,000 frames. We have stride, so this is a prediction on essentially every 60th frame. I have a pretty decently sized unified memory architecture on my Mac here, so I'm going to set the batch size at 16 and then click predict. And what it will do is fire through this video and predict on every 60th frame for labeling. If you zoom in, you'll see the confidence score associated with that label, and then you can click and drag to sort of seek through your video um, to see where your labels are. This is a really great way of iterating on your models to find areas where it's performing poorly. So if I click send lowest, it will take the lowest confidence predictions from that sort of quick and dirty inference pass that I did. I'll select 5 frames again here, send them to your labeler. We'll find a poorly labeled low confidence frame here. So this animal sort of buried in the corner with bad reflections. We'll do a single frame prediction using the 4 key to draw that picture from that model. We'll replace the key points and then click save, and now it's added to your data set. The next thing we're going to do is I'm just going to resize this to get this out of the way a little bit. Let's say you want to train a new model, so you want to train and create your own data set. If you click validate labels, it will loop through all of your data just to make sure that for every image you have a set of valid and corresponding labels. Um, I'm actually going to show you one more thing before we do that. If we go back to key point, we have visibility mode as well here too. So if I go to the tailbase and click on it, if I don't remember, I just redrew that prediction. 1 second here. If I click the V key, what I can do is make key points invisible, which means the model learns that that thing is sort of not in the frame. So if an animal that rears and its nose goes out of the actual video capture window, you would label that key point, but is invisible. Red is visible and in focus, and this yellow is an occluded point. So if its nose is under some bedding or in a nose poke hole, it will learn to place that key point, but it will do so when it is occluded. All the points are visible here. Just going to resave that really quickly, and then let's create a data set. I'm going to rerun validation really quickly. We're going to click export data set. We're going to get a split, a train val split ratio here of 80%. So 80% of our data will be training, 20% will be validation. And then it will ask us if we want to train a key point model, so bounding box plus key points, or just bounding box only. We'll do pose here. Click OK. And then what it will do is create a dataset folder in SqueakPose Studio. You'll see pose. It will create a YAML file, as well as your train and val splits with all of your images and all of your corresponding labels. Cool. So now if we want to train a model directly from the GUI, what we can do is go to that dataset path. We got to click into pose once more to see where the YAML is. We're going to open that. We can select a model size. We're supporting 11 for YOLO right now, and we'll add more over time from N to X. This is just the number of parameters that are tunable in those models. Just going to train a really quick and dirty, lightweight 11 nano model. It auto detects that I'm on a Mac, so I have MPS acceleration from the GPU. The training task will be auto-defined. It can sort of look at the YML files and determine if you're trying to train a pose or a detect-only model. And then I'm just going to run 10 epochs quickly, again, with a batch size of 16. On CUDA-enabled devices, the batch will show up as auto. It will auto-select the number of samples that you can fit in your GPU memory and then automatically batch size for you. And then all we have to do is click Start Training. If we now look over here at our terminal, we'll see we'll upload the Ultralytics package for training with all of the augmentations sort of preloaded. This is training from a random initialized backbone weight, so there's no transfer learning being done here. We're sort of training from scratch. It will run a quick validation to make sure that all of our images for our training and validation set are correct, non-corrupted, and that there's no backgrounds, so just nothing without any labels on it. And then it will create some data loaders, and we're just going to run a 10 quick epoch training set. What it's doing here is it's showing you the epochs as they train and then as they validate, and then you will get some sort of key instances out of this where you get this MAP 50 and MAP 50 to 95. This is the number that you want to see climb as your models start to learn. We've also implemented early stopping here, so you can select, I think, 999 epochs. And when the model stops learning, it will auto stop after 100 epochs of not performing any better. So we're not going to overfit or overtrain our models. Once this is done, in 2 seconds, it will tell us our performance on the validation split, and it will save the results. If we go back to this runs folder that we shipped, I'm going to click OK and close to stop those terminals. If we go to pose now, you will see that we have train 2. So this is the run we just ran with all of our metrics here. So it obviously didn't learn anything. That's okay. As well as our batches, as well as our validation batches. If we go and look at the models that we're shipping with, you can upload the results PNG and see that these usually train for around 400 to 600 epochs and continue to perform over time. And again, your MAP 50 to 95 is really your metric for how well these models are going to perform. Um, So we've trained a model from the GUI, and let's say we want to finally do some inference on full videos. If we click inference, it's going to ask us to load a video file. I'm going to go back to the video that we are using for demo purposes here. And it's going to ask us for a batch size. I'm going to click 16 again and click OK. And this is what you will see on every single frame prediction with a batch size of 16. I'm not going to let this whole thing run, but as you can see, this is moving pretty quickly. In the paper, we talk about benchmarking these sort of inference times and frames. But I'm just going to cancel this. We've gotten through 2,000, almost 3,000 frames in a minute or so. And then it will tell you where the output is saved here. So if we go back to, oops, sorry, inference outputs and open up this CSV. Sorry for not opening this in Python, but for every single frame that you do a prediction on, it will tell you what video it is, what model you used, what frame index in the video, convert it into time in seconds based off the FPS that you're recording on, how many detections you have in the frame. If you have a single animal, it should be 1. Your detection index should be 0 because that's the class index. We don't have track IDs implemented yet, but will when we do all multi-animal support. Again, with the class ID, class name. This is the confidence for the prediction, the X and Y coordinates of the upper left and lower right box, the width, the height, the area, the center of the box in X and Y, the normalized centers in X and Y's, the widths normalized. So if you resize your videos, you can change your image width and heights. The speed that it took the model to actually do this, so the pre-processing, so loading the image, prepping it, the actual inference times, the 10 milliseconds per frame, and then your post-processing speed to write those predictions back to essentially the CSV. So this is just a box, and you have all of these for every single key point. So here are your X, Y confidences normalized for the head, for the tail, and this is for every predicted frame. You can export this into our included data analyzer toolset, or take it to your own pipeline for analysis, or port this into tools like Zebra or Keypoint Mosaic to do some fancier detections. That's sort of a quick and dirty overview of SqueakPose Studios. This is a full GUI to label, train, and do inference on your small animal behavior data. Um, if you have any comments, suggestions, leave them in the GitHub forum, and we're going to continue to iterate on this. But that should be a quick demo of how the tool works.